the firebox is. So, the openings between the bricks and the grate. And I started to understand what is expansion joint, because the brick expands with heat, and how the fire goes around the floor of the chamber to then get inside the chamber to heat the pots. And I'll go back to this image where the fire rises from the side and then goes down into the flue hole. Now, if there was no bag wall, the fire would just basically scoot into the flue hole very easily. And I'll be showing more diagrams as we proceed in the presentation. So how does fire work? Like, what are the things that are needed for heat to be created? There are three basic things. That is air, which of course is available all around us. We exist on air. And it has oxygen, which is needed for the fire. We need fuel, and fuel can be of many different kinds. And the third thing we need is heat, because if you have tried lighting a fire, for bonfire, or lighting a wood kiln with, small pieces of wood, if you light it, there are many times it just extinguishes and it becomes smoky, It needs heat. It needs a little bit of hot temperature for it to then create a chain reaction, which makes the fire. So there are three things: oxygen, fuel, and heat, which creates a chemical chain reaction for fire to happen. And when we are working with the kiln, then all these three things are really important, and the understanding of it is important for our work. So now that we know the triangle of fire, we will go over the fuel part, because, as I mentioned, that we have air everywhere, we have oxygen everywhere. Heat will be generated by the fire itself. Then is fuel. Now, fuel are of so many different types and kinds. I have put first on the list wood, because I like to wood fire, and it's a renewable energy source. We can grow it ourselves. And it was used by people from all different regions of the world to create fire, to create pots, to keep themselves warm. Next is biogas, which is another ecologically sustainable fuel, which could be cow dung, renewable fuel produced by breaking down organic matter, such as food scraps or mammal waste. And there are quite a few industries which are using biogas, not only in ceramics. Hopefully in ceramics, we are able to create a system to be able to use that. Gas, of course, the butane gas that we get in gas cylinders that we use for firing. It is a clean burning fossil fuel. The only thing is that it has been created in the formation of Earth over millennium years. So it remains to be, it's going to get exhausted over a period of time. And so is coal, which is mined, and it cannot be renewed. But all these are fuels that can be used for creating heat and firing kilns. So moving along, kiln. I think that the basic definition in my mind of a kiln is that it is basically a chamber which withholds heat for a particular duration of time. whichever fuel we use, that is what we are looking for. We are looking for a place where we can, a space in which we can put our pots and it can hold the heat so that our clay can vitrify and become, get the molecular structure of granite, which happens in millennium years on the Earth. We do it mechanically in our kilns. So I think I thought very simply to jump in to electric kilns, which are basically a simple chamber which are lined with electrical conduits. And for the electric kiln, one could be producing the electricity in many different manners, whether it's hydroelectric, whether it's coal, whether it's solar for that matter, hoping that, we'll have solar energy more prevalently present all across the world. Electric kilns are usually plugged onto a 15 ampere volt plug, and you can fire your work with that. And these electrical conduits radiate heat. So that's what you can use for vitrifying your clay. Surface decoration, most people in electric kilns, using electric kilns, do surface decoration before they put the work in the kiln. So I have one work, just to give you an example, that I fired this in an electric kiln to cone 6, which is 1200 degrees centigrade. And I made a list of people whom I know who create amazing work in using electric kilns. And as I mentioned, that they do a lot of decoration, surface decoration, before the pot goes into the kiln. So yeah, that's about the first one. When we get into understanding gas kilns or wood kilns, where we are using gas or wood as fuel, the chamber will need to have a place where the fire enters the chamber and a place where the fire exits the chamber. So here are the 3 different types of kilns, different styles, or dependent on how the fire is moving inside the chamber of the kiln. So the left-hand side most is a cross draft, where the fire enters from one side and it travels in the chamber and exits on the other side. In a downdraft kiln, the fire enters from one side, it rises up, and it has to turn down to get into the flue hole and go through the chimney. So because the fire has to travel downwards and back into the flue, we call it downdraft. Though there is an overlap between the cross draft and the downdraft kilns, and you will see several kiln designs where that is evidently present, and then there are some that are clearly downdraft kilns. And we'll talk about it as we proceed in the presentation. Lastly, there are kilns which are just a structure, and the heat enters from bottom or closer to the ground and goes up and out of the chamber, it being called updraft kiln. Moving along, the first kiln that I said I fired many, many times, and I understood, oh, no, I'm just going to jump to the gas kiln that I built at my Earth Art Pottery in Pondicherry, and it's a downdraft kiln. It was essentially 2 burners having the heat come in from right next to the chimney. It would heat up the chamber, like rise in the chamber, go down into the flue hole, and then out through the chimney. So this is an 8 cubic feet gas kiln, which I designed and built. And I created a small sketch of essentially what is in there, which is an 8 cubic feet chamber with burner ports on the back and the flue right in the center of it. The fire rises and goes back into the flue, and this is the side view of the kiln. Some images of the interior, and in this one, because I was making various sizes of sculptures, I kept the bag wall loose, which means that if I was putting one big sculpture in here, I had much taller bag wall for the heat to rise before it went down into the flue hole. With the kiln, where I have more densely packed shelves and pieces, I had more space left in the bag wall for the heat to come into the chamber. This is a glaze-fired kiln as soon as I opened the door. And one result from this particular kiln, and that's another one. Because I built this kiln after I had worked with wood kilns for almost 9 years, I tried to create surface qualities like a wood kiln would provide you. So I sprayed the glaze, keeping some of the areas of the pot unglazed. So it was directional spraying of glaze that I did on these works, and that worked really well with the kiln for achieving these results. Those are some of the students who, one of them is a current student at Utah State, and some who are alums from here who continue to make amazing work in gas kiln firings. And I thought that it would be a good way to see what they are doing using gas kilns.
Antra, did you fire that? Sorry, just 1 second. Just tiny information bit. The gas kiln that you fired in for cone 10, correct?
Correct.
Correct. And it took you how long to reach the peak temperature, and how long you were holding on to that?
Yes. So I did 5 firings in the kiln, and I think that I had not achieved an exact one system of doing the whole firing and holding. The firing generally was 14 hours. I would start in the morning around 6. Well, let me say like this. I would preheat it overnight. So in the morning, it would be around 200 degrees centigrade. And then I would start cranking up the heat. And I would finish around 9:30, 10. I would reach temperature. I would, in my, what should I say, theoretical manner, I would like to reach cone 6 by around 6 or 7 p.m. and then reach cone 10 by 9:30, 10 p.m. and then soak it. I would not keep it at the peak temperature. So for example, if on the pyrometer I have 1220, which is not cone 10. Cone 10 is 1300 degrees centigrade, but on the pyrometer, it might be showing 1220. Then I would have that cone 10 touching the cone pack, and then I would bring the temperature down to 1200 and then keep it at that for half an hour, 45 minutes. And then close the kiln. By closing the kiln, I mean turning off the gas from where it begins, like switching it off at the cylinders, and then letting the gas burn, and then let the gas go through the chamber and become fire and leave, and then shut everything. Yeah. Any follow-up question?
Maybe later on, everybody can ask questions. Just go on with. Sorry, I disturbed you in the middle.
Oh, no worries. That was a good question. All right. So then I am going to talk about the wood kiln that I fired many times at Golden Ridge Pottery. It's a downdraft kiln, and it is. I mean, I don't want to assume, but Fred Olson's Fast Fire is a prevalent name whenever we are talking about kilns. And Ray Meeker had done an alteration to that design, which was very convenient to fire. But before I move any further, I do want to show you the book called The Kiln Book, and this might be showing up like mirror image to you. I'm sorry about that. But The Kiln Book by Fred Olson. So this is like, a really good reference book. And Fred Olson has built many designs of kilns across the world. And his Fast Fire kiln made to India, I think, way before I knew about clay. But Ray's design of kiln is essentially, he covered the firebox with a system where the heat did not radiate out onto the person who was firing the kiln. It was essentially embraced in the brick walls so that the heat was going inside the chamber. And I have the kiln design here, which essentially shows, the firebox itself, and the fact that there are air holes for at different times of the firing. One would need different amounts of air. So I would like to address the triangle of fire. There's a certain amount of oxygen, there's a certain amount of fuel that is required for generating heat. And once you have lit the fire and the fire is going, then the heat is always there to continue the chain reaction. Now, the amount of oxygen is dependent on the amount of wood that you're putting in the kiln to give the temperature rise in the chamber. And that's why the air holes are important, because when you begin firing, you need less fuel and less air. And as you gain temperature in the kiln, you would open those holes to get more air such that it can burn more fuel and give you the resultant heat in the chamber. So thanks, Kanjan, for reminding me about the kiln firings. Now, these kilns, I would fire from 6 in the morning, no preheat. I would start firing on the floor at 6 in the morning and reach body reduction around afternoon 4. No, body reduction around just after lunch, like around 2, which is 900 degrees centigrade to 1100 degrees centigrade. And then get to cone 6 by 6 p.m. and generally get cone 10 by 8 p.m. And in this kiln, I would definitely soak for 30 minutes. And again, depending on the pots that are in there, the glaze that's in there, I would alter that from 30 minutes to 1 hour of soaking in the kiln. I remember one time I fired Celadon in this kiln, and I literally just reached temperature. I stoked a lot of wood and I sealed it all up. I did not do any soaking, and I did get nice greens on that Celadon. So it totally depended on what glaze I was firing. But the examples that I have here are of these platters, which I fired in the 25 cubic feet kiln, which I just showed you. And in this one, I would soak it for 35 to 45 minutes in the firings. All right. I do have a few chat messages. I'm just going to quickly look at them and see if there's any question there. Okay, this was a while back. Thanks. All right, moving along. I've mentioned a few names of people who have this Upma kiln at their studios, or they work in the studio where this Upma kiln is. So that's just to for you to see their work. Okay, so then I will talk about the wood kiln, which is a downdraft. And this was a catenary arch wood, and it could be fired with wood and or gas, which was built in Alibag by Joe Finch, and it was a workshop which happened in 2013. It might have been 2014, if I might be mistaking 1 year. But yeah, so this essentially is a downdraft kiln as well, with firebox on 2 sides and the chamber in the center. The fire would rise up and go down. And in this case, the flue was under the floor and then go back in the channel to go up through the chimney. I made a quick sketch of this, where we would start the fire on the floor on either side, and then there are grates on which the wood or the gas burner would heat up that firebox. There's a partial bag wall, and the fire would rise, go all the way through, like screen through the pots and the shelves, and go down under to these flues, which would connect, and I'll come to the side view where it would connect to the chimney, and there's a damper to navigate how much amount of air is going into the kiln. And I would like to mention that the use of damper is as crucial in limiting or adding the amount of air that is going into the kiln. And I'm sorry that I did not mention about the damper in the previous kiln, but it does play a very important role in all kilns that we fire with a fuel, which is, which is not electricity. So, so the holes that allow air to go in, and the damper, which controls the air which is leaving the chamber and going through the chimney, both are really important in burning the fuel well for heat in the chamber. So yeah, so this is a catenary arch kiln. And that's me stoking that particular side stoke hole. And when we unloaded, you can see that there are these shelves, and you can see this hole here. And there's an image from right in the front where the heat, the flame has to go down under the floor to leave the chamber. Some examples from that kiln. Some names of artists who have catenary arch kiln. I know Suhana is in Australia, and Joe Finch, of course, who conducted the workshop. He's from England. You will see their works as an example of the kiln firings. Now I'll go on to wood kilns, which are a combination of cross and downdraft. And these kilns, these climbing kilns are called Naborigama because that's what they are originally from Japan, and they were called Naborigama. But I was firing this kiln in Australia in Robert Barron's studio, and this left-hand side image is of the front of the kiln. The time when I was in that studio, we were doing the 50-second firing. And Robert mentioned that he used to treat this front dome as a firebox. So it was just a place for burning wood. And I will have another image where we will be seeing the chambers, which are, you know, what you see, the wall is part of the first chamber. And there were 4 chambers in this kiln. But in one of his 25th, 26th firing, there was a part which rolled down from the first chamber into the firebox. And he really loved its results. So he started stacking pots in this chamber, and which is, you know, on the right-hand side, you're actually looking into the interior of the firebox, which used to be the firebox. And now he loads pots here as well. Anyway, so basically there are pots here, the wood burns in this chamber, and it travels through these holes into the next chamber. And the climbing kiln diagram in Fred Olson's book is like this, where the heat goes into the chamber, rises up, goes down, and moves into the next chamber and does the same. So here are images of the chamber. This is from the picture from the side. And you can see the height of the kiln. Nina, who was an assistant to Robert Barron as well, was almost about my height, which is 5 feet 3 inches. So you can imagine that these are pretty much like 7 feet tall chambers. And out of 4 chambers, we filled 3 chambers. We let one of the chambers stay empty. And you can see how these big planters and smaller pots are loaded up. And the fire is coming from the right. It would rise up and then go back down to go out of the chamber. And there's another close to completely stacked chamber. And here I'm actually starting to unload, but basically the whole thing was bricked up, and we fired this kiln for 5 days. It took exactly the same number of days to cool down, and the results were as desired. We did introduce salt in the last chamber. And so you will see that that is, you know, I have the image from the salt chamber on the left, and the right-hand side is my work from one of the chambers closer to the firebox. Any questions? Okay, well, I you know of only one artist who is working with climbing kilns. I know there must be many more, but in my radar, there's Robert Barron, and he does not have an Instagram page, but a Facebook page, and he has many of his works shared in that. So that is the example of climbing kiln. Then I'll come to Anagama, which is a single unit kiln on on a hillside. So it's also climbing, but it's just one chamber. And it's cross-draft kiln. This is the monster. In Japan, we gave it the name Monster Anagama because most kilns in Japan are really small and tiny and long, but this is almost 4.5 feet tall right here and was a really big kiln. So as I mentioned, it's a single chamber cross draft, making the use of the fact that heat rises up. The stepped chamber helps with that, the movement of heat in the kiln as well. So that's the view of the stack in the Anagama in Pondicherry. And these on the right hand side image is of the pots which were buried under the wood. So what we did was that, of course, these steps had shelves and pots on it, but there was a stoke hole on the side just in front of the next step, and we put pots all the way across. But after 800 degrees centigrade in the kiln, we would introduce wood on top of those pots in that stoke hole. And if I remember correctly, well, it's not if I remember correctly, it is true that we learned this technique by Peter Thompson, who was a resident artist at Golden Bridge Pottery. And, you know, we emulated that and have been using it ever since. So that's what is this right image on my slide. And then a few examples of the work from this kiln. And then Ray built a tall Anagama, not monster anymore. But this is well, I should compare the size. The Monster Anagama was a 100 cubic feet kiln, and this is an 80 cubic feet kiln, which has 2 steps, and it is about 5.5, perhaps 6 feet in the center at the highest point. And this was, I would forget.
They still call it Chinnagama.
It is still
Even if
called
it's in.
the small Anagama in Golden Bridge Pottery. Thank you, Kanjan. And I think that there's Sandeep and Ray, myself, I think Akila, Ranjita, I forget which workshop this was, but anyway, that's the kiln and the interior of the kiln chamber. And as I mentioned, it's a cross-draft kiln. So the wood is burning right next to the pots, and that really gives a good amount of wood ash deposit on the pieces. And in these cases, we try to use wadding to create surface decorations. And those are a few examples. If I remember correctly, the Chinnagama has been fired in many different ways. The 3 or 4 times that I have fired it, we fired for 60 hours. And then in 3 times, we just soaked for another 6 hours and closed the kiln. But in one of the workshops, we down fired, which means that we closed the damper and let the whole chamber smoke and let the whole kiln cool in that reduction atmosphere. And I believe we've done that in Tim Rowan's workshop. And I do not have results from that particular firing, but you know, it changes the surface quality because of the atmosphere. And that's where I would like to talk about the fact that when we kept the peephole open for a long time, It was basically sucking in oxygen. It was sucking in air into the chamber. When you are trying to do reduction and you want the oxygen to be pulled out from the clay, you don't want a lot of air going into the chamber from other openings. So that was my story from Baroda, which I connected here. So moving along, wood kilns, continuing on the train of wood kilns and talking about Train Kiln, which is a design by John Neely, who is my advisor at Utah State University. He is responsible for designing a Buri box chamber in the shape of a train wagon, and you will see it in this particular image, where the chamber is pretty much like a train wagon. And instead of putting wood on the floor like we do in the Anagama, we start the fire on the floor, but we stoke, like after 700 degrees Fahrenheit, which is about 300 degrees centigrade, we start putting in wood on the top, which basically means that the draft is not rising the heat and taking it somewhere else, but actually pulling the heat into the chamber. So it's going down into the chamber, going through the flue into the chimney. So this is the most efficient way of burning wood, because the wood is not just piling on top of each other, but has space to burn efficiently. I see there's a message. There's a message on chat which says, will you be discussing the Raku kilns? I have, to answer your question, Manisha, I have very little experience with Raku. I have done a few workshops, but no, I don't have that in my list of kilns here. So yeah.